more than one basis. So there are infinitely many bases in a linear space. So there are many bases. So if you keep on changing your basis, definitely your matrix will change. That so matrix is what? It is totally dependent upon basis. So basis wise matrix of the linear transformation, it will keep on changing. So I will talk about those things, how the matrix of a linear transformation with respect to basis is dependent on change of basis matrix as well. Also I will talk about how to find a coordinate vector with respect to this change of basis as well. So the two applications I will discuss in detail in today's class. Outline of my today's lecture are the following. First, I will give a recap of change of basis matrices that we had already discussed in last class. Then I will talk about two different approaches of finding coordinate vector. One approach, it will be based on solving system of linear equation. That means a Gaussian elimination method, system of linear equation, or linear system calling. So that process, what I had already discussed in first module, Gaussian elimination methods. So based on that, we will find coordinate vector of a given vector with respect to a given basis. Another approach would be change of basis matrix. So that those two approaches, if you are very good in these two approaches, then definitely you won't face any problem in finding coordinate vector of any vector with respect to any basis. Now, after that, I will talk about the relation between change of basis matrix and the process of finding matrix of linear transformation with respect to different bases. So your linear transformation is same, but due to change in basis, you are getting different matrix representation. So with respect to a single linear transformation, you will get a variety of matrices. So what are the relation between those matrices? Relation is similarity relation. So those matrices with respect to a linear different bases happens to be similar matrices. Similar, this one is an equivalence relation. I will discuss in detail those things. So coming to recap of both change of basis matrix, in last class I had already discussed that the different view of change of basis matrix, that we had a vector space, n-dimensional vector space B, and then with respect to this vector space or linear space, we had two bases. We had taken two bases. One basis was A having element B1, basis element B1. So element in basis, we are calling it basis element. So element in first basis A, it had remember this notation is what? This curly notation, it is calling it actual A notation. So somehow it is a stylish A, you can say that. So that's why I'm calling this one is A, and this one is a notation of actual B. So these are different style of writing A in a fancy way. So we are taking first basis A, having basis A element V1, V2 up to Vn, because V is a n-dimensional vector space. That's way in the basis there would be an element. I would like to mention dimension of V here n. Equal to n. And second basis was what? Second basis B, it was another basis of the linear space B with the basis element W1 and W2, W3, like those process we are going. W1, W2, and last basis element of second basis B was Wn. So we had two bases for a given linear space. So we then first we are talking about change of basis from basis A to B. So this is the matrix of change of basis from basis A to B, and second matrix, this one is talking about the change of basis matrix from B to A, and it can be established as by the relation between these two. It can be established by solving the equation. That means it says that if you take any vector, and one more thing you can say that when you are changing basis from B to A, so B you can here in this situation B you can call it old basis, and A is the new basis, because you are going from alt to new. So that's way. So if you take any vector from the vector space B, so what would be coordinate, new coordinate? So this one is, you are saying that you are going from B to A, so that's why this one is new coordinate. New coordinate is written as a product of change of basis matrix from B to A times alt coordinate. This one is alt coordinate because it is talking about coordinate of B with respect to B, that first basis. So this one is alt coordinate. So similarly, so after solving it, we can write this one alt also, that coordinate of vector with respect to given first basis B. That means alt coordinate also you can write it as a inverse of change of basis matrix time new coordinate. But we are already having, if you are having a relation that suppose here you are going from basis A to B. Here, remember that the direction is very much meaningful here. You need to know that direction, what direction it is. So here, this one is saying we are going from A to B. So in that process, our new coordinate vector of the given vector B would be V with coordinate of V with respect to B, and all coordinate of vector B would be coordinate of V with respect to basis A, and this is the change of basis matrix from A to B. So this one we are having again that definition of change of basis matrix. If you observe these two from here, you will observe that change of basis matrix from A to B is nothing. It is actually inverse of change of basis matrix from B to A. So this is the relation between these two change of basis. Either when you are going from A to B, and when you are going from A to B, then what is the name of your change of basis matrix? Change of basis matrix, that means you call it as A to B. That means change your A to B. And when you are going from B to A, your change of basis matrix is what? Change of basis matrix is S B to A. B to A. These are the visualization of change of basis matrix. So the relation I had already discussed. So simply suppose I am taking S as a notation of change of basis matrix from A to B, then change of basis matrix from B to A, it would be what? It would be S inverse. Same thing we can call it in a very layman way, that it says that new coordinate vector is the product of, that means anyone, whether you are going from A to B or B to A. So same scenario, you observe that new coordinate vector is the product of change of basis matrix, that means and the alt coordinate. Now if you try to look change of basis matrix, what does it what kind of column it is having? So column of change of basis matrix happens to be are the coordinate of the coordinate vector of the old basis element with respect to new basis element. This one is the layman approach to calling change of basis matrix. Okay, so I have given a diagram for all these happening. So you are having a vector space B, and with respect to this basis A, you can map every element of, that means you can find coordinate of B, and that would be an n-dimensional vector. So that means you are defining a coordinate transformation from V to Rn, because V is n-dimensional. Similarly, with respect to basis B, you can define B coordinate transformation from V to Rn. Now, once you are coming in Rn, then what is, so these are talking about coordinate space. This one is the coordinate, Rn is a coordinate space. This Rn is coordinate space with respect to basis A. This Rn is a coordinate space with respect to basis B. Then what is the relation between these coordinate? You can find relation by multiplying S, change of basis matrix. That means if you are going from B to A, then your coordinate here, it would be, that would be new coordinate, that would be multiple of S times this coordinate, alt coordinate. So that is the relation. And this one is the max. macroscopic view, and this one is the atomic view, that element wise view, that vector wise view. If you observe, so a vector wise view will come like this way. So both view I have already given it here for the purpose of a better picture of change of basis matrix. So a few example I was discussing in last class. I could not complete this example in last class, so I have to complete today. So here what V is a subspace of a smoothly continuous function. So simply consider it is every subspace happens to be a linear space within itself. So that's why V is a now once it is a subspace of C infinity, you can itself consider V will behave like a linear space with it is having two bases. So two bases intensely we have taken. So suppose V is a two-dimensional subspace of C infinity, and which are having two bases. One basis is A with basis element e to the power x and e to the power minus x, and second basis is what B having basis element e to the power x plus e to the power minus x, and second basis element is e to the power x minus e to the power minus x. Now we have to find the change of basis matrices. That means when you go from A to B, you are changing basis from A to B. Then you have to find what change of basis matrix. Your change of basis matrix would be S A to B. Then you have to find change of basis matrix when you are changing your basis from B to A. So in that time you will get a change of basis matrix B to S B to A. So these two basis change of basis matrix you have to find it here. So first we will find change of basis matrix from B to A. So that means how can you find? I had told that when you are going from B to A. So the coordinate of any vector with respect to A would be, we will call it new coordinate, and coordinate of any vector with respect to B, we will call it old coordinate. So column of this matrix S to B, what it would be? Easily we can look it into here. So take here you can look at what e to the power x e to the power x plus e to the power minus x. This one is your new basis element, and so you would like to represent this one with respect to old basis. So it would take this form. It one time e to the power x plus one time e to the power minus x. So we can say that coordinate of this basis element with respect to basis B. What is the coordinate of basis element of A with respect to basis B? What is that? That one is 1 1. Similarly, coordinate of basis element of A with respect to basis B is, it is 1 minus 1. So that's why you got your desired matrix having first column 1 1 and second column is 1 minus 1. Okay. Another example I would like to take. So suppose you are taking A as a standard basis of Rn, and B is any non-standard basis of or arbitrary basis of Euclidean space Rn. Then we have to find the change of basis matrix. So it is very simple to find change of basis matrix when you are going from B to A. So B to A, it would be just what? If you are going from B to A, so change of basis matrix would be like this way. Column would come directly from the non-standard basis B. Non-standard basis B. So like this way, it is coming like. I had mentioned that the relation between from the relation between the coordinate, old coordinate and new coordinate, through that you can easily get this kind of thing. So I will take one more example. Now we are taking a plane. This one is a plane in R3. So definitely this plane, it will have just two directions. That means if you take any basis of this plane, that would have exactly two basis element. So we are considering two bases of this plane. One basis is a1 a2 having a basis element a1 a2. A1 is what? 0 1 minus 1, and a2 is what? 1 0 minus 1. So these two are basis element, first basis element. Now take second basis element, so b1 b2. What are b1 is 1 2 minus 3, and b2 is 4 minus 1 minus 3. So we are having two bases for this plane. This plane, it is passing through origin, so definitely it would be a subspace of R3. So we have to find the change of basis matrix from B to A. Then we will find change of basis matrix from A to B. And also, you don't need to find directly in a similar process B to A. Just find the inverse of A to B, then you will get that matrix as well. So by inspection, we observe that what is B1? B1 is 2 1. How? Because B1, coordinate of B1 with respect to A. What is the coordinate of B1 with respect to A? It is 2 1. That means you multiply A1 2 times and add with A2. What you will get? You will get the vector having coordinate 1 2 minus 3. That means you will get B1. So through inspection, you don't have to, otherwise you have to apply Gaussian elimination method. So through inspection, you can come to know that B1 equal to A1 plus A2. Similarly, through inspection, you will come to see that B2 is what? It is minus A1 times minus A1 plus 4 times A2. So that's way coordinate of B1 with respect to A is 2 1, and coordinate of B2 with respect to basis A is what? It is minus 4 minus 1. So this will come as a first column, and this would go as a second column. Remember that we are going from B to A, that, and B here in that pattern we are saying that B is our old basis, and we are finding the coordinate of old basis element with respect to new basis element in order to get change of basis matrix from B to A. So this is the change of basis matrix from B to A. So here I will discuss about two different approaches to find the coordinate vector of a given vector with respect to different bases. So two approaches I will talk about. So we consider this one is non-standard basis. I had already mentioned that what is the standard basis of R2? A standard basis of R2 would be E. We denote it by E. And what are the basis element of standard basis of R2? Basis element would be 1 0. That means direction of x-axis, and direction of x1 axis, and direction of x2 axis. This one is a standard basis. So we are not taking this basis, but we are taking a non-standard basis. That one is having first basis element is V1 having entry 3 1, and second basis element is V2 having entry minus 1 3. And also you can observe that V1 and V2 are perpendicular to each other. So it is a nice kind of basis, non-standard basis. Now we are taking any general a vector from R2, that one having coordinate 10 and 10 with respect to a standard basis. That one, this one is our given vector. So we will first find. Also, we are having another vector Y whose coordinate is 2 minus 1 with respect to this non-standard basis. So, but we don't know why. What is why? So here question is that we have to find coordinate of given vector x and the factor y whose coordinate with respect to this non-standard basis is 2 minus 1. So we are having two questions. So we will solve this one in two different approaches. So one approach we will solve with the help of Gaussian elimination method. That means we are first going to find coordinate of x with respect to basis b using Gaussian elimination method. What does it say? That we are taking 10, given vector is 10, 10. So we will express first as a linear combination of the basis element of this non-zero alpha 1 or alpha 2. Then we will say that definitely it is a it is a two-dimensional vector. Definitely it would be in R2, and due to that it says that definitely we are going to get alpha 1 and alpha 2 as a non-zero value. So just write this one in the matrix form. So this is the corresponding matrix form of this equation, and apply Gaussian elimination method over this augmented matrix, and this is your reduced form. And from reduced form you can observe that what is the value of alpha 1. Alpha 1 is here 4, and alpha 2 is what, 2. Alpha 4, by solving it this reduced system, you will get alpha 1 equal to 4 and alpha 2 equal to 2. So that's way coordinate of the given vector x with respect to basis b, new basis b is what, 4, 2. So your coordinate has been changed. Initially this 10, 10 was the coordinate of this given vector with respect to this standard basis. If nothing, no basis is mentioned there, then by default always we say that the basis is standard basis. So that's why this vector is given with respect to a standard basis. But now we change this basis from a standard basis to this non-standard basis b. So here now coordinate of the vector would be changed as well. So here what is happening? We are not changing the point, we are just changing the coordinate. So that means we are changing the representation. By allowing change of basis, we are changing the representation of a vector. We are not changing the point. Point is the same, but the way of looking is changed. So that is the concept of finding coordinate with respect to different spaces. So what is the second approach? One approach, first approach I discussed about Gaussian elimination. Second approach is change of basis matrix. For this we need a change of basis matrix. So what is the change of basis matrix? Again I told that find this in order to find change of basis matrix from B to E. What could be that? It is very simple to find change of basis matrix with respect to B to E. E is the standard basis. But and similarly, what would be change of basis matrix from E to B? That would be inverse of this one. Why it is very easy to find change of basis matrix from non-standard basis to a standard basis? Because here the column of basis change of basis matrix would be what? It would be coordinate of old basis element with respect to new basis element, and your new basis here for this change of basis matrix from B to A, new basis is here. Just see the representation right now, forget about this problem. See the representation, try to see in local way. It is saying that we are trying to find change of basis matrix from B to E. So here our old basis is B and new basis is E. E, that means a standard basis. And so in order to get this change of basis matrix, what we will do, we will take basis element from B and we will find coordinate of those basis element with respect to a standard basis element. What are the basis element? First basis element is basis element of B is 3, 1. It is B1, that means having coordinate 3, 1. And 3, 1, this 3, 1 is what? With respect to a standard basis by default. So that's why first column of this change of basis matrix from B to E coming as 3, the vector itself. And second column would be again coordinate of second basis element of B with respect to a standard basis. This is already in a standard basis, with respect to a standard basis, that's where second column would be minus 3 1. Now we will see that how to find y, but y, that means we are already given here. So here now we are right now finding coordinate of x with respect to b. So we have to find coordinate of x with respect to b, and here in order to find coordinate s with respect to b, what we will see that that means now in order to solve this problem, we see that we are changing basis from E to B. That means here in this case taken vector x is any it is a given vector. We are finding a coordinate of this one with respect to this one would be a new coordinate of x with respect to b, because we are changing this from E to B, and it would be equal to what? It would be equal to change of basis matrix from where to where? From E to B. Then we will multiply this change of basis matrix with old coordinate of x. What would be old coordinate of x? That means uh, coordinate of x with respect to basis E. That would be old coordinate. But here remember that we haven't, for simplicity, we haven't calculated change of basis matrix from E to B. We had calculated change of basis matrix from B to A, and we know the relation that this one is what? This one is just inverse of this one. So in place of change of basis matrix from E to B, what we will take? We will take change of basis matrix from B to inverse of change of basis matrix from B to A. So that is the criteria. That's where, because this matrix is easy to find. Change of basis matrix from B to E multiplied with old coordinate of x with respect to E. So remember that here inverse is coming. So don't confuse with all the notation. Try to understand the meaning. So what would be inverse of this change of basis matrix from B to A? It is just a 2 by 2 matrix. So what will happen here? Apply the same process. Diagonal element, it will be interchanged, and here of diagonal element they will change the sign. It is a way to find, and also divide by corresponding determinant. So determinant of this matrix would be, what is the determinant of this matrix? It would be 10. So 1 by 10 times this one. So if you multiply this S inverse with all coordinate of x, all coordinate of x is 10 10, and after simplification you are getting 4 2. So this is the new coordinate of the vector, given vector x with respect to basis P, non-standard basis P. That one is 4 2. So this approach is based on change of basis approach, and this approach is based on Gaussian elements method. So we are getting the same answer from two different approaches. So it is way to find coordinate vector with respect to two different approaches. One is Gaussian elimination, another one is change of basis. Next question is that we are trying to find y, whose coordinate is given with respect to non-standard basis. So with respect to non-standard basis, coordinate is what? 2 minus 1. Again, we will solve this problem through two different approaches again. So one is Gaussian elimination, another one is change of basis. So through change of basis, what we will see that so if you are y is having coordinate with respect to b is 2 minus 1. So from here, from the definition, easily you can use that you are saying that 2 times b1 plus minus 1 times b2, and b1 and b2, b1 is what? 3 1, and b2 is minus 1 3. If you simplify, then you are getting 7 minus 1. 7 minus 1, what is this one? This one is your y. That means coordinate of the vector with respect to standard basis. This one is y. From the definition you got y. What is y? Now again, if you are willing to solve this problem, to find y with respect to change of basis matrix. So we had already seen that coordinate of y with respect to non-standard basis is 2 minus 1. So this, and also we know the relation between change of we also know the change of basis. This is the change of basis matrix from B to E, B to E, that means a standard basis. That's why y would be what? Y just we have to multiply this. You can say that here your old y is now new basis because you applying the operation your change of basis from B to A. So coordinate of y with respect to uh, a standard basis would be y itself, and this one is a change of basis matrix from B to E, and this is the coordinate of odd coordinate. That means coordinate of y with respect to a non-standard basis B. So if you multiply this matrix, you are getting your desired result, desired vector y having coordinate 7 and -1. You can see that both relation are matches to each other in both approaches. This you got from division, and this you got from change of basis matrix. So the representation I had already plotted it here. You can observe like so. This one is x1 and x2. That means x1 and x2 are talking about what is the direction of x1. Direction of x1 is it E1, or you can call it 10. That will define your standard basis E, and this is x2 axis. So what would be direction of x2 axis? That one is E2, or you call it in the vector form 0, 1. This one is 0, 1. Now you are having a, so these two are forming E, a standard basis E. That nice representation, we are very much familiar with that. Now we are taking two vector v1 and v2. So these two in together, they are forming another non-standard basis p, and you are trying to express every element with respect to this v1 and v2, that with respect to basis p, that means you are finding the coordinate. So it is a graphical representation for everything. You can look it into here. You can represent all those things here. So if you are calling y is 7 minus 1, where would be 7 minus 1? That means you are walking 7 lot of unit along x1. So 1 unit, 2 unit, 3 unit, 4 unit, and up to 7 unit. Then you are walking negative -1 unit along negative direction of x2 axis. So your point somewhere it would be here. This y point would be here with respect to a standard basis. Okay, you got it location. Now same point, if you try to visualize from v1 and v2, what would be coordinate? Coordinate is with respect to v1 and v2. Coordinate is 2 minus 1. But if point is same, now coordinate has been changed. You are saying that you are walking 2 unit along v2 axis, then this v1 axis, then you walk negative negative unit along v2. So this one is negative direction. That's why you are. So this is, so same point is having coordinate with respect to non-standard basis is what? That one is 2 minus 1 is coordinate. That means 2 unit along v1 direction, -1 unit along v2 direction. But if you try to see same point with respect to a standard basis, then you will say that you are walking 7 unit along x1 axis, then you are walking 1 unit along negative x2 axis. That is accurate. Point is same, representation has been changed. So it is just talking about representation. So how you do allow those representation? So by definition, or by change of basis matrix, or by Gaussian elimination method. So I will talk about one more application of that change of basis matrix in process of finding matrices of linear transformation. So here we consider a vector space V, which is having two bases A and basis B, and we also consider, apart from that, we consider a linear transformation T from V to itself, V to B, that means V to B. Then we say that A is the matrix of this transformation with respect to basis A and B is the matrix of this transformation with respect to basis B. So in that process, we would like to say that A is A matrix and B is B matrix. That this just notation it is changed because why? Because this one denote basis and this one denote matrix. So that's why notation is changed. No. So what we will do? We will find this matrix with the help of change of basis matrix. So overall picture is already given here. So how can you find that? So we take S as the change of basis matrix because we are having two bases from two bases A and B. So S be the change of basis matrix. So suppose it is from B to A, then we know that finding S inverse would be change of basis matrix from A to B. There is a inverse kind of relations. That's where anyone change of basis matrix find it, and then other also you can find it. Then we also that means if you take any vector V, then what kind of relation we will have? That means we are going from B to A. That means our new basis is here A and old basis is B. That means coordinate of V with respect to new basis is A. New coordinate of V with respect to A is equal to S time. S is the change of basis matrix from B to A. S time coordinate of V with respect to old basis B. This is the relation. If you generalize this one is for one vector. If you what you do, what is A? If you say A, if you are willing to find matrix A, what is the matrix A? So recall that process of finding matrix of a linear transformation with respect to a basis. So that time basis was a standard basis, so it was very easy. So if you are having a standard basis, how you find matrix of a linear transformation? So suppose we are having a linear transformation from R2 to R2, and a standard basis is E having in basis element 1 0 and 0 2. So how you will find a matrix of this linear transformation from R2 to R2? So it is given by that first column of this matrix would be what? Just it would be image of basis element, first basis element E1 with respect to a standard basis. So with respect to a standard basis, it is not needed to write here a square bracket because it would be the vector itself. You know that what is the coordinate of 1 2 with respect to a standard basis E? It would be 1 2 itself. That means coordinate of this one with respect to a standard basis is what you are it is saying that one lot of this vector along 1 0 and two lot of this vector along 0 1 direction. So that's coordinate. It is meaning of coordinate of a vector with respect to a standard basis. So it is what if you simplify this one. So what kind of form it will take? It would be the same vector itself. So coordinate of a vector with respect to a standard basis, it would be the vector itself. So you can say when you are finding coordinate of 1 2 with respect to E, it is what a standard basis E, it is the vector itself. So that's way I am writing here. Find the uh, coordinate of the image of E1. Image of E1, it would form first column, and similarly coordinate of image of E2, second basis element with respect to a standard basis. So it would be T of E1. So this one is the change of basis matrix from sorry, this one is the matrix of transformation from R2 to R2. So that's way here if you are coming age what age A basis matrix, age A basis matrix, it is age a transformation age the matrix of transformation with respect to basis A. So what would be the first column of A? First column of A would be definitely we have to find coordinate of image of basis element. So suppose V1 is the first basis element of A in the basis A. So we have to find coordinate of this TV1 with respect to A basis A, this fracture basis A, and likewise you have to find another column. Last column would be what? It would be coordinate of image of Vn with respect to first basis A fracture. This one is your A matrix, and similarly, what is your B matrix? B matrix is the matrix of transformation. This transformation with respect to second basis B. So it would be what? Here your coordinate of image of W1. W1 is the first basis element of B. So you will write, you will find coordinate of image of W1 with respect to second basis B, and it will go like this way. So here the definition of matrix of transformation with respect to these bases, it will give idea that A and B are related as A times S equal to S times B. Or simply here this we had already seen that S that change of basis matrix, S is change of basis matrix, it is always invertible. So further you can write it A equal to SB into S inverse, or B also you can write it S inverse AB. So if you are having any matrix, you are and you express that matrix in terms of other matrix with the help of non-singular matrix, then this kind of relation we are calling it similar relation. I will take one example, then through example things would be clear much better. So here I have taken vector space B having two bases A and B, and we are defining a linear transformation from V to itself. That one is the derivative. Linear transformation we define by derivative. So we will find a matrix of this linear transformation D derivative, that means derivative transformation from B to V. Then we will find what would be the basis of this one with respect to first basis and with respect to second basis, and then also we will see the relation between these two matrices as well. So we are having, take any element from this vector space. So that would be what? It would be, now we have here we are dealing with first basis A, fracture A, first basis. That means basis with basis element it is power x and it is power minus x. So if you are taking any general element, it would be what? A scalar multiple of our linear combination of basis element. So that means that would define coordinate of that element from V, and here similarly you apply linear transformation over this general element, and linear transformation, this linear transformation is what? It is derivative operation. So that means you need to differentiate this element from the vector space. So after differentiating it, what you will get? What is derivative of it? Is A times e to the power x? It would be the function itself A equal into e to the power x, and our derivative of second term would be minus, negative would come from here from the exponent. So minus B times e to the power minus x. So what is the coordinate of image, pre-image or domain element? It would be AB, and coordinate of this image element with respect to basis A. With respect to basis A, it is what? A minus B. So here by inspection directly you can get matrix this one. How? Because A minus B you can write in the form of matrix vector product like this way. So that means A means how you are getting A when you multiply row 1 0 with AB, and how you are getting minus B when you multiply row 0 minus 1 with AB. So from here just by inspection you got your change of uh, matrix of transformation. So this is your, you got your message. This is the matrix of transformation with respect to first basis. Now similarly if you are willing to find a matrix of transformation with respect to second basis, you don't need to find directly using the first matrix. You can find, so there are two different approaches to find uh, second matrix. So with respect to A, directly you got the matrix this way, and with respect to B, if you are going, then what would be your A would be like this way. Okay, other things, it is already 45 minutes, so we'll discuss other things in next class. If you are having any question, you can ask. Otherwise, in next class onward, what I will do, actually, in tomorrow class, it would be your assignment class. I will assign few problems you have to solve during the given hour. And in next week onward, I will start next module. That one is orthogonality. So rest of things are very simple, like this way. A matrix you have to find with respect to different uh, basis. So next week onward, we will start